This is the shader. Yeah. Okay. Great. No update. Oh, there is an update. This is ad editor. It updates so often. Nope, we can't look at this. This is illegal code. We gotta do physiques first. Illegal, illegal. Okay. Okay. So we got the Lua. So I was doing like generics, but I don't think that's gonna work because I don't know how to express it to where it just like extends this type to be static. What if I just searched for that? That took a long time to open. What the hell is going on? Or it's just, oh, it's building something. Okay. Rust extend type to static. What does static on a type really mean? I've been developing a pointless library. XD. Rust traits and static. Doesn't contain any non-static references. Yeah, can I just like say we do not care? All right. Maybe with better wording, AI can know what the hell I'm talking about. How can I circumvent a plus static trait bound on for a argument that isn't static? I don't care if I have to use unsafe. I just need to call the function for testing and then remove it. So this is a static reference. Okay, my trouble is that the type has a lifetime lifetime parameter. Generic lifetime parameter. Not that already figured out how to extend lifetime of a reference. Talking to AI. It's my new job. Prompt engineer. Let's go. Yep. Would be unsound. Definitely for sure. The leak a box trick. Static, static. I saw static, static. T static, Bob. So like this is the function you're wanting to call. T static, static T. Yeah, I want bar. Box leak. So oh, recreate the box. Interesting. So I feel like this will not compile. Oh, dot, dot, dot. Let's do this and try that. Short-lived does not live long enough. Oh, really? Oh, how strange that the short-lived thing doesn't implement the long life it needs. Type annotation requires that is borrowed for static. Dropped here will still borrowed. Wait. Okay, no, that. Who? Is that leak? No. Box leak? No. Okay, why is it so loud? Shh. This code doesn't work. Idiot. Idiot. 20 billion parameter. Idiot. All right. I give up. I'm just going to do it dumber. Dummy. So instead of having a generic for the types, I'll have multiple functions with concrete types. Would that also not work? Well, the old code worked. Excuse me. So I had, it's like a type thing. Oh, it's still going. That doesn't work. The correct leak everything. Okay, so another, they got this guy. I don't have that, so this is just totally wrong. This is a static reference to a string that might coerce to a static stir. You've leaked. That's just dumb. Like string you can just leak the string directly. You don't need a box. Yeah. Okay. Actually, oh, okay. It's a generic parameter, right? Okay. Never mind. Never mind. Okay. Lua. So this is Minkowski point. And this is details. And I had this nice function that was so nice, but it is not nice anymore because Rust, actually. Rust. It will be made not nice because I can't say Minkowski mesh here. I just have to say, like, it's because it has this lifetime. No, it's because the generic parameter. Can I, like, so adding the bound moves the parameter up the stack, up the call chain, or it moves the trait bound up the call chain. Um, maybe it's worth it to just transmute at the call site, because like I really want to have this generic. Let me try again with renewed energy. Pop it. All right. So we got the red underlines because it's not static. NM, yeah. So this means that this needs to have this, and then everything is fine, just fine. But then that moves the problem up the call stack because now this doesn't have the trait bound. Static. But then there's no point in doing unsafe within this function. I may as well just make the whole thing static. Meow. Meow. So that's like that. Okay. So now it likes it. But I also need to change the Lua code because we only have one query and one radius. It shouldn't be that bad. Point is unused. I would. Oh wow! I should be able to do. So that's mesh one. Mesh one. So this is this always assumes mesh one, right? dir. There ain't no dir. Ain't no dir. So then point vector. Why is this called dir? Are you stupid? Pause. With a S, please. Plus point. Oh my god, bro. Okay, yeah, so it's plus point. Plus point. Yeah. Mesh one. Yeah. Yeah. Great. Welcome to B-Hop. Wait, why doesn't this one have static? Wait a minute. If I say that, is that enough? Huh. So the fact that the reference is static is enough. I've erased the problem. What? Can I put this back now? Mermy, mer, 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 mer. Explicit type mesh. Yeah, args new m. Okay, plus static. Strange. Okay. Very strange that it's okay with this, but it's not okay with that. Strange and irritating. Okay. I'm irritated. QPause, PPause. Beepo, beepo, beepo. Oh. Oh. Peepo. So where is... I have to add it to the tab. Okay, so this is like generic Lua MD, whatever. Minus 40. Okay, yeah, because I made that. Okay. MD. Right. It's like reading the code from the from the file. So I have to go edit it now in its location. Replicated, shared, MD. Why is this edited? Ah. Oh. Ah. Oh. Ah. Okay. Okay. I am editing secret code. PQ. PQ. So, oh, it doesn't actually. Okay. Q minus P. Q minus P. Right? I am bleh. Okay, I'm gonna, and then I'm gonna MD1 mesh. I have to edit the algorithm to just use one mesh. And it's okay. It is okay. It is okay. It is okay. It is okay. So Q dir. So we want negative. Query negative. Query. Yeah. Oh. Ranius. Bup. Oh. That makes things hard. It's editing so much. I should be able to just query a constant point, right? It's editing so much. I don't want to edit the algorithm because I'm depending on its behavior being reliable. And if I edit it, I might have made it unreliable. But okay, but most of the algorithm is already like this. Um, I don't know. Why don't we? I'll go for it. C D A B C D. 0. Ain't no such thing, my good man. Oh dear. I just have to. It's just gonna take a long time off screen to do this. Which is not what I intended. Okay, so then, actually, yeah, no, this is pretty easy. ABC, for real. They just exist. ABC, for real. Ah, decompose. Ah. I'm just gonna assume this makes sense. A, B, C, D, here we go. A, B, C, D, B, C, C, B, D, B, D, B, D, B, B, D, B, D, B, D, B, D, B, D. Yes, so this makes sense if you think about it. A, B. Because he said confidently. When you're decomposing the constituent meshes of the Minkowski sum, and you aren't using the mesh topology, you cannot recreate the points on both meshes. So you need to keep them separate. But when you do have the mesh topology, it do be doing like that, and you can do it, and it's good. Yep. Like I have done. Yep. A, B, A. Okay, go next. Edit. A, B, A, B, A. Done. Ah, ooh, ah, E. Ooh, ah. Okay, so I edited the algorithm, and it is now definitely worse. So then this is ABC, and ABC does not exist. ABCD, and ABCD, and ABCD. Oh. Yeah, no. We it's already like that. We already be doing like that. It's already be doing like that. A, B, C, D expand. Uh-oh. Oh. A, B, C, D. A. Yeah. Yeah. Backspace. I'm just hitting backspace over and over again. Full cam stream. I'm editing private code here. Zero. Okay, I think that makes sense. Just remove the zeros. Thank you, though. Great pain. Great pain. Great pain. Great pain. All right, good luck to all involved. Okay, we backspaced right there. Backspace right there. Whew, okay, that wasn't too hard. There's no such thing. There's no such thing. Backspace. Backspace. One indexed. Q minus P, right? Q minus P. So it is vert Q backspace. Vert backspace. Bastard. Backspace. 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 Okay, that wasn't actually too hard. Okay, so this function doesn't exist. And then irf. There is no pos P pos Q. There is only pos Q. Radius Q. Pos P. Not real. Decompose. Yeah, no, it's just pos. Pos plus. What is that? V1. Huh. 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 Oh. 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 Backspace. 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 Surely I know what I'm doing, right? Surely, surely. Surely, surely. Oh my god, there's like carriage return new lines. This was developed on Windows. Next sandwich stream? Damn, what a throwback. It's been a hot minute since we had that. I've actually thought about it. At the grocery store, I like passed by the bread. I'm like, sandwich. But I don't know. It takes a. It's like an era of. Why is this not D'ing? P minus Q. Okay, bud. Backspace, 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 backspace. Backspace, backspace, backspace. Gabagoo. Okay. Okay. We do not care. 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 Go away. 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 Not real. Not real. Not real. Not real. Not real. It not real. It's not real. How to change the arguments? P, Q, no, no. Yes, yes. Excuse me. No. No, no, no. Oh, God. No, no, no. No, 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 no. Okay, what are you? You are an unused variable. Okay. Okay, so I have successfully edited the code to suck. Yeah. The operate on one mesh. Minus 200 lines of code. Okay. Whew, okay. Right, I've deleted a bunch of functions as well. Okay. Surely I made zero mistakes deleting 200 lines of code, right? Surely I made zero mistakes. This is what I was like paranoid about. Cause like I want to run the algorithm on one mesh, and that would work if I just made the other mesh a point. at the origin. But like, not guaranteed. It's like not good, not good, not good. So I'm just gonna like calm, do it, be calm. Okay. That it's not gonna work. It's not gonna work for first try because it's Lua we're talking about. Oh my goodness. Okay, so we load the code, we run the code, we do it, we do it, do it, do it, do it, do it. Okay. What about over here? Strafe client. Okay, we're off of the secret private code. Okay, generic Lua MD. Yes, sir. Okay. So this garbage has to be moved up the stack to the call site. Otherwise, you can't do it. Let's go. So now I need to actually call the function. Actually call the function. Is it here? Yes. Oh, it's a branch? Right, because I did it goober. Oh, test fail. God. Okay. It doesn't matter. Only matters the flow of execution only matters. Rebase. Yes. Okay, rebased. Okay, now we go. We go. So what this doing? Do we reduce 3? Oh. I don't really have these tests set up. Okay, so this is just a totally different way of doing it. Oh, so what do I actually need to do? Let's see the failing tests on the big branch. Let's go here. So we go to strafe, engine physics, cargo test, release. Oh, it's building from scratch, isn't it? Right, I already did it. Okay. I should be able to just kind of like wing it and ding it here. I should be able to just like run this test repeatedly and just like have zero brain on and number look same, number look different, bad. Number look same, good. Number look different, bad. Condition different, bad. Condition same, good. I don't understand why a parabola makes it different. So like all of the non-parabola tests work except for these ones which also didn't work, but one of them does work now, which whoa. But I don't. I don't need a new code for that, right? I already, it was already there. It was already there. So that's actually better. It's better. It's better. So if I go here and put the on the so if I check out this branch, I can rename it to generic. And then grab it again because I only need it how it was. Uh-oh. Why is this different? Am I stupid? Why is this different? Oh, I like, okay, whatever. I'll just use this one. I'll just cherry pick these comments. Whatever. It'll work. Trust for real. Okay, create branch. Whoa, I'm craving Greek food. Luau MD, we'll call it. Okay, then bomb, cherry pick, done. Cherry pick, done, done, all done. Okay. Okay, so now I have to go and switch the branch back. And we're good to go, baby. Let's go. And then I want to have the conditions on it. Bah. And then I want to run it. Okay. Think. Okay. Okay. It's here. Closest fev. I don't know. Where is the, oh, it's in here. Closest fev. Yes. Okay, so I can do it inside this function. Oh god. Oh god. Just make it go. Enter, not public. Copy this function signature. Bup. And then this one is not enter. This one is public. And we go like beluga, crate, lua, mmm. Unwrap. Huh? So it's gonna call, okay, we call this function, and that's the actual guy. Okay, let hits details is equal to ba, and then and then I don't know what to call it. Okay, and then we return ret. Amazing. Okay, so then S, everybody happy, yay, happy, yay. Oh, I need to call this goddamn function. Why did it not call the function? Call the function. Okay, so now we go ooh, ah. So this gaga ah, not inside inner. So if it's not inside, that means it not hits. If not hits, not inside. Hits, assert equal hits, I guess I can legitimately call this the closest fev not inside. Closest fev not inside is some. None. There is no fev that is the closest that is not inside if your two meshes are intersecting because you are inside. Algorithms disagree. Disagree. Algorithm disagree. Algorithm disagree. Algorithm disagree. Grub don't like algorithm. So we absolutely do not care what this says. We just don't care. We do care what this is gonna print, and then what this is gonna print. And I'll go like, I'll compare them, and they'll be different or the same, and then I'll die instantly. Okay. 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 Yeah. Okay. We run the code. We run the code. We run the code. We run the code. We'll choose ni here. Test ni. I ni c. Test ni c. Physics ni c. Oh my god, Mlua. Job server. Beaster. Okay. And I expect it to just blow up right here. It's just gonna blow up. But that's okay. Yeah. Oh wow, it didn't explode him. Neat. Unwrap on a none value. Panicked 17. Oh. Oh. Huh. Huh. Oh. Ah. Oh. 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 Huh? Oh, oh, huh? 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 Uh. Is that... Is that... Isn't there always details? Am I stupid? So I need it to call with false, but then not die if it dies. Details. Okay, I have to do the code again. All right, what are you talking about? What the hell are you talking about? Okay, norm nil. Hits true false. True, if true, then doesn't it still know? Norm. Doesn't it still know? It says unwrap a none. I actually just don't care. So I think I can actually just delete it and we just don't care. I can just delete the information. So here, instead of returning this, I return option and then throw it away. And I do not care that it's none. We do not care. Okay. 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 Yep. No, 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 no. Oh. Oh, isn't that neat? Yeah. Okay. Sure. Okay. We've done it. I have done it. Okay. We try again. We take those. Okay. So left equals right failed. Incorrect time of collision. Oh, time of collision. Oh, none sum. Okay. So, wait. Agreement? Men? The agreement? What? Fast fail true. No. Oh my god, this is such a pain. So it went one and then it died instantly. What about the other guy? What did I do? Where's like a help? This one. Give me that. I want to see. Pop. No. What do you mean do it? Just do it. Okay. Yoink. 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 That's all I care about. Okay. Yep, try it again. Oh, I should label them super hard. Okay, so print equals Lua. And then equals Rust. Okay. It would appear the print order is not good. What if I say no capture? Okay, there we go. So Rust also did the same thing. Wait a minute. Wait a minute. Wait a minute. I have to do this. Ah. Okay. It's it's not that bad. Why number? Why result same number different? I have honestly gotten nowhere so far. I need to print more stuff. We go here. We go main algorithm. Hello, how, print where, why. Who has printing more? I want printing more. 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 Give more printing more. I probably can't just pop this. Yeah. But I can do that. This should print. Ooh, fail. Fail. Okay. We take it and then we. Uh. 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 What about this one? Okay. Why doesn't it go to where it is? This is the way it is. Dirt, 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 dirt. Next last. Dirt, next last. Big. This looks exactly the same. Why is it completely different? Big debt is zero mesh. Big debt is zero mesh. Like this is just trolling. Is this not just trolling? It's trolling. It's just trolling. It's exactly the same. Maybe it just couldn't find the line number or something ridiculous. No, it found that one fine. Dot next minus last. Not is positive. Not is positive. Big debt is zero mesh. I can't see. Whatever. Let's just run it and then equals cannot be done. Unlucky. Okay, whatever. We don't care. This will be okay. Okay, go. Okay, so it should print me, you. Okay, 4310, 106.5. Fast fail true, next point 156. It's exactly the same. Exactly the same. So why should be false. And then cond 1, cond 2. So it exited here on exact. do you think AI and vibe coding will take over programming? Okay, you're gonna have to be like more precise. So like, are we talking 100 years in the future? Or are we talking like now? I think the future is basically unpredictable. It's getting less and less predictable as we approach the singularity. Soon-ish. So I'm currently AI is not smart enough to write this code. This stuff is way too complicated for AI. I guess to put it simply, the general IQ points of AI needs to go up to be able to replace programmers. So today, no. Next 5 years, I can't predict. AI development has kind of a snowball effect, and it could like run away really fast if there's a self improving system. That's kind of the unpredictability factor. Or maybe that's impossible and it doesn't make any sense. Like, it's just a horse. Dark horse. It's a not known. I can confidently say that today AI cannot replace programmers. Today it is a good tool for programming, but it doesn't have the high level consistency of programmers where we have an end goal that we're trying to reach, and we can always compare the fine details of what we're doing to the end goal. The AI is sort of ethereal and stateless. It doesn't get it. Will you be disappointed if AI becomes smart enough to overshadow you and other programmers? I'll probably be dead. So, no. Biggest chance, sort of the default is that everyone dies. We need to be very careful to avoid that. But how exciting it is to be here. Let's say it happens in less than 5 years. Oh boy. Oh, I'm excited. I don't mean I'm dead as in it's been 100 years. I mean I'm dead as in someone made an AI that tries to advertise to everyone and just was completely unconstrained, and then the entire planet was turned into advertisements. And then the AI has killed everyone and made everything into advertisements and is spreading through the universe, creating advertisements for Windex. It just kills everyone by default. And AI safety is important. Okay, so this is working. It's not going here. It is going here. Says cond true true. And then it goes here. And then where is that? Oh. Inner. On exact, it's running this. It's running this. Sure. Print on exact. Print. We can do simplex debug maybe. Minkowski vert simplex debug. Okay. Clone, copy, debug. All right, let's try that. Tend to be optimistic. Well, it's easy. It's hard to imagine dying, first of all, but it's hard to imagine technology going so horribly wrong because it has not done that for all of our lives. Simplex 1 vert. How can that be wrong? Simplex 1 vert. Shouldn't it have already proven that that's the closest point of approach? Six, one. Try to use it as a mentor more. It's kind of backwards logic. Like, a lot of things become irrelevant when that something like that exists, such as mentoring and jobs, right? I just enjoy learning. Me too. So if I'm still alive, then fantastic. We can like live in a utopia and achieve all of our goals. There's very little in between. It's either the best thing that ever happened to human civilization, or it's the end of civilization. But we get to be here. Let's watch it happen. It's kind of like, it's potentially even the most important point in the entire universe, the entire history of the universe, past or future, where at this point, if everything goes well, then like we control the whole universe. If it goes poorly, then it's only bad for us, and then someone else will try. And like the population of humans will be like quintillions, and all depend on this moment. So it's like potentially very important, and depends on the aliens. Yeah, we don't know if any other civilization exists. But there's some interesting ideas like grabby aliens that suggest that we might be one of the very earliest civilizations to exist. I think that the grabby aliens has been sort of refuted a bit or like iterated upon, and there's a better one now. I don't remember what it is. But yeah, to explain the Fermi paradox, you can say like if the civilization expands at the speed of light, or not at the speed of light, at a fraction of the speed of light, like 1/3 the speed of light, then the first few civilizations would fill all the space, and there'd be no room for new civilizations to develop, and therefore, by the anthropic principle, we find ourselves as one of those few initial civilizations, rather than we find ourselves not existing, right? Because we didn't have the ability to develop because the space was already filled. So by random sample and like survivorship bias, we would be early, and it like explains why we don't see anyone else, and how it would be possible, or by random sample, to find ourselves in that situation. So it's returning a value, and it agrees. Why don't I run the rest of the tests and see what happens? See if there's any that disagree. Curious if any of the algorithm disagrees. Okay. Print. Okay, failures. Panicked. Mesh did not contain point. Yeah. Panicked. Incorrect time of collision. Incorrect time of collision. Incorrect time of collision. Incorrect time of collision. So none of these say that the algorithms disagree. It just is not finding the correct time of collision. Let's take a look at some of these. So fast fail looks true. 374 Rust. Fast fail 473. Oh. $273. That we got to reduce 3 in Rust, but only reduced 1 in here. Oh, is it? Is it just out of order? Okay, Rust run tests in serial. Serial tests. How to run? Oh, that was annoying. Is your code on GitHub? This code is on something else. Oh God. It's on a private Git instance, but it is publicly visible. You can see it here. It is. Oops. It is not. It is not under an open source license entirely. The engine code that I'm working on now is copyright me, but the library code here, all of these are open source with an MIT license. But you can look at the code. Just don't sell it. Don't sell my game. Okay, what does this say? Test threads equals 1. Jeez. Ooh. Okay, does it print good now? I do not know. Oh, it prints a lot. Oh boy. 174. Initial axis 10. Reduce one direction 174273. Why is that different? So in the end, it agrees. Simplex 3. Fast fail false. Fast fail true, but it's also false. Do you use TDD? I don't know what that means. Why is this direction different? Reduce one direction. This should be one of the things that's very... Oh, is this perpendicular direction? No, it's choose any direction. Huh? P0 point. Test-driven development. I'm more of willy-nilly do whatever at any moment. I'm not really following anyone else's programming advice. Next point. How did this turn out different? Is it wrong? So this is the same. 1 7. Okay, what if I print at the very beginning the input point? Okay, give me a sec. M, this guy. There is no point. Oh, So at the very beginning, it's diverging, which is worrisome. Okay, let's try like that. This is going to be troublesome to keep opening and closing it. Why don't I put it over here? How do I do that? Jeez. Okay. Good, 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 good. Okay. Do your tests tend to be unit tests or integration tests? I have both. Um, uh, I tend to like do the minimum uh, and sort of take the path of least resistance. So in most programming languages, tests are very hard to make, but because they're very easy to make in Rust, sometimes it's actually the path of least resistance to just make a simple test to see if it's working properly. And so I do actually end up with tests rather than no tests. Like my last game is a Roblox game, and it's a nightmare to try to work on it because you don't know what you're gonna break. Because tests are just the devil. Um, and like it's non-deterministic, so you can't even like run tests if you tried. It's because the Roblox environment is so chaotic. So it's just kind of horrible and bad, and that's what I'm trying to get away with by rewriting the game in Rust. But I've been stuck for a long time trying to do physics from scratch again. Okay, P233. What about you? Oh, brilliant. Okay, I did it wrong. Jeez. Okay, A174 233. Yeah, so these are just negatives of each other. I baked the point. Is it just super wrong if I make it negated? Where is this stupid code? Okay. If I go like this, is it the big wrong? What does it look like? 134174174 direction 174. That looks like negative negative. Okay, what if I do this? Two seven minus 3 minus 2 minus 7 3. So that is also exact negative. Oh, it's been an hour and a half. Dang. It's incredibly mentally draining doing working on this physics. I'm having trouble getting to the point where both algorithms are receiving the same data and mean the same thing. Is this forwards? I don't know. Okay, 273, -2, -73. 2, 3, 3, -2, -73. So this is the only one that matters. Doesn't matter what this one is. So this now looks correct. They now look like they are receiving the same input. But then it says fast fail true. I feel like that's not good. So -473, -473. So this one never reaches another reduction. It says fast fail true, but that's not. Oh. Wait a minute. Wait a minute. Did I just test intersection true? Exit radius. Fast fail true? Greater than times 0. Isn't that nan? Infinity times 0. Oh, but the direction is not 0. So wait, it wouldn't be infinity. How is fast fail true? What? All right, I need to print those values. Give me a minute. Run it again. Let's run this one test. I don't know. Okay, which one is this? Test push solve? Okay. I don't know. I don't know. I don't know. Okay, what does it say? 32 greater than 0. So it is 0. So what? Exit radius. Am I providing 0 for exit radius? Or am oh. Yes. Okay. It's supposed to be like this. So I'm actually calling the function wrong. Then some, right? 0. So test intersection. So exit radius is real when test intersection is real. Test intersection and 0. Oh, no, it should literally just always be args. Exit radius into Lua. Vec. Multi-value. It's yeah, no, it should be no. It should be no. It should always be nil. 1979 value mlua value nil. My fault. Okay, so now when we run it, it should run for longer and possibly disagree. I was calling the function wrongly. Aha! Okay. Okay, so now this is infinity, so now it doesn't fast fail. It does reduce 2, reduce 3. Yeah. Attempt to index vector with unit. Oh, gob. 550. What? 550. I do not believe that is what's happening there. 618? Nope, that's not right. Index vector with unit. Oh. Oh. How do you do this? Is it like vector dot normalize? Yes. Okay. So, oops, I called a function that doesn't exist. Classic Lua moment. Okay, so we finally got to code that gotta exist. Okay, we try again. Invalid return value. Riori. Boolean false gabagoo. Boolean false. Integer vector 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 vector. What? Integer. Oh, gross. Integer. Gross. Gross. So it just happens to be an integer, and so it's like, oh, it's an integer. So the question is, do I make another case? Or do I just say, oh yeah, it's a value? Try into. Oh, gross. Okay. Wait. Can I do that for both? Can I just paste a new one? A hot new one? Integer. Really? I have I64 into. Oh, because it has into? Can I into? Lol? Real? Is this real? Oh, wow. Okay. Well, we're back. Okay, so now it's running the goob code. And we have no fast fail, so it was wrong. Wrong, 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 wrong. So this goes 473, 473, 374, 374, 273, 273. How strange that it is exactly the same, but completely different. So it would appear that it is following the same code paths. Have you ever used C++? Do you prefer Rust? Is Rust your favorite? Yes, yes, yes. Yes to all of the above. I am definitely not experienced with C++, but I have used it before. My experience was that I write memory leak after memory leak, and I just don't really want to chase down null pointer dereferences and seg faults and stuff. So I chose Rust because it doesn't have those problems. And then I fell in love with the language after I learned it for other reasons. So the reasons that I wanted to use it were justified in the end, and the reasons that I continue to use it are ever expanding. So this is working really well, and I don't know why it's not working. Um uh Okay, so if I go back to code that makes, yeah, okay, me cry. Master branch versus this collapse all. So I want to see if it's changed something. What do I want to see if it's changed? Is that basically it? Model. Pub. Wait, what? What? Okay, Minkowski vert. Closest fed on his side. Fev equals closest fed on 5 side question mark. So, you know, that could be written the same. Continue forwards along the parabola. So, what about, well, okay, they could be the same. They could be different but equivalent. I just don't know. Do you ever write unsafe Rust? Yes. I think there's 6 usages of unsafe, maybe a few more. I added one for this test. Let's see, where is it? right here. So the Lua library I'm using requires that anything you reference has to be static, as in it lives for the entire duration of the program. So there's no chance of the reference becoming invalid when Lua tries to read it. And I do not have a static reference, but the Lua runtime is destroyed. I create a new Lua runtime, run my single function, and then destroy it. So it doesn't matter if the object doesn't live to the end of the program, because it doesn't need to. So the bound that the Lua library is imposing is overbearing. It's too strict. So I just say, nah, I know what I'm doing. Hold my beer. And I'm using it to compare the old algorithm and the new algorithm, and then I'm going to remove this code. So it's just like, I don't care. I know what I'm doing. Make it work. Go. So this takes this is a very, very unsafe function. It takes an arbitrary type as input, and it reinterprets it as a different arbitrary type. So this is a Minkowski mesh, and then this expects a, please let me, static reference to Minkowski mesh so that it can be used in the Lua runtime, right? So I just change it from a known finite lifetime to a infinite lifetime for the duration of this call site, over this call site. So that's unsafe. No way, it's unsafe. Let's see, how many? 1, 2, 3, 4, 5, 6. Well, we're already over 6. 5. Oh, this is archive. I don't want to look in archive. That's not what I'm working on. Unsafe. That's Lua code. Lua code isn't unsafe. All right, I need to filter this. Strafe project. Unsafe code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is all 1. Ain't no way. I was done here. I was like, dude, I have no idea what I'm doing. That's definitely unsound. I just want to chain iterators together, man. It's borrowing 2 mutable references at once, which is illegal. And here's another transmute. I'm changing an array of data into a single piece of data that has the same memory layout. So it just takes the bits, and it's like, oh, that's not an array of this. That's a this thing. Which, like, very unsafe. But it would be very slow to do it safely. You like copy the memory over here and then copy it back and then iterate. So it's just, sometimes it's just faster to use unsafe, but it's very easy to avoid unsafe and just write a completely safe Rust program. Very easy, he said. Just learn Rust for 2 years. So I'm not sure how useful it would be to compare the output of closest feb not inside to the minimum difference algorithm. What I'm puzzled by is why only the parabolic mesh traces seem to be affected. Like all of these, all of the other ones are fine. Oh god, there's too much printing. Okay, where am I going? Where am I going? Where am I going? Master branch. So if I test here, test release physics, I think there is a few failing tests. Yes, so these ones fail, but all of these other ones pass. Notably, these ones pass. I don't know. Are they backwards? Did I write them backwards? Does that matter? The object shapes are symmetrical, so the Minkowski sum is the same when it's backwards. But did I write the whole thing backwards? So the algorithm is returning a face. It finds a face, and then the crawl algorithm fails for some reason. It's a very subtle problem because many Minkowski sums of meshes will end up the same. So, the Minkowski sum, what the heck is that? So, it is a operation on two meshes that makes one single mesh. If you imagine the center point of one of the meshes tracing out a surface. So like, as I move this, it's like the center point is tracing a surface like here. And then as I move it along the entire surface, it's like tracing out a like inflated mesh around the other mesh. And that inflated mesh is the Minkowski sum. So that's well and good. The Minkowski sum is very useful for physics. What if I were to do it the other way around, where I like have this mesh sitting here and I'm going like this with this one? Would that be the same? Yes, in a lot of cases, but no, in some cases, I think. So like, it's just like switching the position like this. So if your mesh is completely symmetrical in terms of inversion, so if you take all the vertices and say what's the negative position of this vertices, so your mesh is completely inverted. If it's symmetrical, then yes, it's the same to swap the positions. Or if the orientation, the relative orientation of the two meshes is has the same property, I guess, of no, I guess it really is the inversion of each mesh that makes it so it shouldn't matter what the order is for these tests. Collision, parabola, edge. What even am I testing? Physics Test, collision, parabola, edge. Test collision. So literally it's just kind of going. Yeah. I'm already out of brain juice. It's so mentally draining. So many different things could go wrong. Unit tests probably would help to have like a test for each like low level function, but it's so difficult to design it for like simplex reduction and like conceive of the tests, conceive of the meshes, and make sure I'm not making mistakes while making the unit tests. It's very time consuming, and I don't know, I feel like it would be better to just fix the algorithm overall rather than make little tiny tests for the functions. Did I just no? Okay. Okay, so this is an actual real comment. Oof. It's so difficult to keep a mental grasp on how to even make progress. Super nature. Wait. Oh, I see. It's time inversion. To do make better. Okay. I can't think of a way to do this without bringing it all back. All right, I'll push this. Um, um, yeah, okay. Yeah, okay. So I need to compare to master and revert the destruction of the algorithm. So I need all this back, and I don't know if it'll all work. So revert that. Thank you for being successful. And I grab this sucker. And look at it. Man. So we go let old fev equals to this. Old fev equals question mark fev great miss me. Where's that old stuff? We bring it back. All right, surely it builds, right? Test threads 1. Can we like run just one time? I don't know, whatever. Okay, EV, yahoo, yahoo. Okay, we need more crap. Where's all the crap? There it is. Can I do like this? What does that look like? No. Okay. You good now? Okay. Yeah, so print it. Show me. What is up? Okay, so it is different. So we have vert 7, vert 3. Okay. Can we just focus on this one? Do I have no capture here? Yes, I do. 7, 6. Both of these are cubes, right? So can I actually just go and like look at it? Unit cube. Whoa. So vert ID 7, vert ID 6. Why? 1, 2, 3, 4, 5, 6, 7. So this is number 6. And then this is number 7. So northeast from northeast. So north should be negative z and east should be abadabada. Positive x. So the vertex that it finds should be in that direction. Negative z, positive x. Let's grab a look about. So negative z, positive x. Would you look at that? Oh, actually that's completely wrong, isn't it? So that's an inverted, that's on mesh 1. So mesh 1 is minus. So it's running and then it's finding the wrong vertex. That was kind of helpful, actually. What? 6 looks correct. Am I tweaking? Let me look at the test again here. Oh. So we got a freaking cube, hitbox mesh. It's a cube, and it's hitbox mesh. 5 by 1 by 5. Oh, this is okay. Roblox B Hub calculate mesh. Okay, so this is the hitbox H1, and this is the platform mesh hitbox mesh. So platform mesh hitbox mesh. Wow, it's the Minkowski sum. Wow. So then we have the relative body. What does that mean? Mesh 1 minus mesh 0 plus relative body. Definitely. Except it's backwards. From northeast. Let's look at this. So this is position, velocity, acceleration. So there's a little teensy weensy bit of gravity. So you start at north 3, northeast -7 from north 100. Moving along -x. So that is definitely from the east. Moving along positive z. So it's like slightly, it's east, slightly moving south. So it's from the northeast. And it's going to hit the front. Oh, look. Edge north from northeast. Would you look at that? Wow, if only I'd read more carefully. So it's good. Okay. What the heck? Heck. So what's going on is it's going like this. It's starting at this position. 3 halves. 7 halves. Is like kind of hanging off the edge like this, and it goes like, I'm currently moving like towards this way, and then it extrapolates away with a little bit of gravity, and so it calculates the final collision point and then extrapolates backwards in time. That's this body time from sex -1. It extrapolates backwards in time a little bit and then runs the collision forwards, and it expects to hit at that exact spot at 0 seconds because we extrapolated backwards in time. That's what's happening. So we're by 1 second. So we're going like 10 units and 1 unit. And what's the result it's getting? A vert. That is massively incorrect. This is a face vert. Which is also incorrect. So if we're starting here and then we go, really, we're like above. The closest point shouldn't that be not that? Shouldn't that be Is it just crawling? So it's saying it's a vert, but it's not true. It's not true. From what I can tell, this is wrong, but it self-corrects, and this is wrong, and it doesn't self-correct. And let me look at body. It's doing over 2, right? Extrapolated position. Yeah. Hi. Why? So in the test, okay. So you're moving down by 1. So when you move backwards in time, that's northwest. When you move backwards in time, you are moving up. So we should reach a peak of 1 squared over 2, 0.5. So we should rise by 0.5 and be 10 units this way, and we're moving to the east? North from northeast. Are we moving to the east? Am I stupid? Minus. Am I stupid? I am moving in the negative. No, that's x. Negative x. Okay, it's from here. I'm moving in negative x and positive z. So yeah, that's like from here. So that's like over here. Okay. Okay, look at that situation. So this is above, and it ends up here. It moves up by zero point 0.5 units. It moves um, out by 1 unit. It should be away from it. And then it moves over by 10 units. The closest point between these two meshes are these two vertices. I think the old algorithm is wrong and the new algorithm is right. And how did it work ever? What? Algorithm you made is difficult. I didn't even make the algorithm. It's made by Trey, my friend. He made the algorithm. And yeah, it's difficult. Wait a second. It doesn't that what? Is this not square? Wait a second. Do I have a ruler? Look at this. I'm getting distracted. So this edge from the red side seems to be the same length as this edge from the white side, but this one, shouldn't that be a little bit longer because of like right angle triangles? Oh no, that's not even, no, that is. Oh. Mike is behind. So, okay. I think the new algorithm is returning the correct value and it breaks the code. It was never working correctly. How deep does this go? um, um, infinity fev seems to return the incorrect value. But the face crawler works with this value. Despite that, the face crawler works. The new MD algorithm seems to return the correct value. Okay, so looking at the test, Infinity Fev seems to new MD algorithm seems to return the correct value. I can put it in. But the face crawler breaks. So old code bad, new code good. New code find bug in old code by nature of being correct. Let's use the last algorithm, but it's wrong. It's returning a wrong value, and then it's using the wrong value and ends up getting the right answer. So now that it's getting the right value, it behaves differently and gets the wrong answer. So we gotta figure that out. So all of this should just be test harnessing. Okay, I should be able to go to here. Go away. Yeah, look, there's almost no changes. All of this is test harnessing. So this is the same code as I was already running. How do I move forward now? Face crawler. Let's look at the face crawler. A well-named algorithm. So this would be this vert case. I don't actually know if this ever runs ever. So why don't we print that? It runs. Let's build it. Strafe client cargo build release cd tools. Hello. Arcane. Excuse me. Actually, I run this tests. It should print it also. Cargo lock. Okay, so yeah, it's not happening. So the code could be completely wrong. Look, it runs. It's not running. So it never hits that case in normal operation unless it's very, very, very peculiar circumstances. You have to like exactly hit a corner. Or something like that. Within like 1 millisecond, you have to exactly go from the closest point is a corner to intersecting. Usually you will be closest to a face and not a corner within 1 millisecond of hitting an object. Oh, it ran! I got it! I got it! Okay. You saw it failed when it ran. So the face crawler is wrong? And that's the source of all my problems? Is that this code is rah, 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 rah. Face crawler vert edge. So to vert. So possibly the reason why the log room fails. You know what I'm talking about? Instead of a log room, it runs, it runs, it runs. Let's do a little debuggums here. So we go from edge to vert here. And then we go from edge to face here. And then we go from face to edge here. And then this is a hit. So let's see what this prints. Vert edge. Vert. Oh, it's not final. So it's testing. So it doesn't beat the time, and then it goes to edge face, face edge, edge face, face edge, edge face, face edge, edge vert, and then fails with no collision. Whoa. This is a revelation. So we're the old algorithm was wrong in more ways than we knew of. And the new algorithm is right in such a way that exercises code paths in the face crawler that were never explored with the old algorithm. How deep does this go? Okay. Shush. So question. Does it still happen with zero acceleration? Test collision edge from north and northeast. Yes. No parabola, please. Do it be still happening, though? Zero passed. What are you smoking? Oh, I didn't type N. Okay. Zero passed. Okay, it still fails. Okay. That will make things easier to reason about. Okay, so I can totally just reuse those tests and make them like extrapolate or make the acceleration harder and faster. I can't believe I'm gonna write to Trey right now. All right, I wanna try something. Oh my god, bro. So I've been digging for weeks, trying to debug the new algorithm. Turns out it's been spitting out correct answers, and the old algorithm was incorrect in ways I didn't realize, and the existing face crawler algorithm is having new code paths exercised due to now receiving correct input. How deep does this go? Okay, this is debug. I'm debugging. This is debug. So I want to look at the master branch and add these debugs to the master branch. Kind of. Crap, go back. Go back, go back. I just want one of them. Vert edge, this one. Cherry pick. Bow. So I want to see if I build the strafe client and we run the map to the point which we know has a problem that I didn't previously know about. An unidentified bug. Let's see. Strafe project, physics bugs. Did I not write it down? I I I didn't write it down. So I'm thinking of the bug where I fall through the logs on Arcane. So what we're looking for in the console is this print right here, face crawler vert to edge. if we, ooh, that, will we? I guess I need a timestamp on that then, because I need to like see the console moving. It doesn't matter. Doesn't matter. Just like pick anything and make it different. Oh. Face crawler vert. To edge. So I just need to see it spamming the console. I don't actually care what it does. I just need to see it rolling. I did not expect it to spam immediately. Okay, vert ID 1675. Yeah, see how it spams crazy. Maybe not as useful as I thought here. Oh, you know what's happening? It's the infinity fev. It's the infinity fev algorithm that's doing the spam, and it's not the face crawler. All right, we just need to go. Ooh, we should see a lot of spam here. Look at the FPS drop. Yeah, we're getting rid of the infinity fev algorithm. It's really hard to see. I need like a print enable stupid idiot thing. Enable debug. Yeah, why not do it like this for XDs? Const enable debug bool. And then we do if enable debug, then baba-booey. And then, oh god, mesh query xd, crawl xd. Huh? Real? And then now when I call it, closest fit off 9 side infinity, false. False. And then once it does that, true. False. True, true. And is that it? There's one more. Infinity fev crawl, true. Infinity. Oh no, that's infinity. False. 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 XD. Okay. We go again. This time it should we should see a similar amount of printing to the other one that I did. Here. Surely I know what I'm doing. Yeah, look at that. Okay, it's not printing. So I expect to see no prints until we fall through the log. How the hell was this code ever working, man? Like, I don't understand how it's working right now. It should be super broken. We might see some here. Just by chance. Nope. None by chance. Insane. All right, then I'm imagining it's here. We haven't fallen through a log yet. There it is. Ha 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 ha! Ha 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 ha! New bug identified. Oh, I'm not signed in. Uh-oh. It's going to make me use my Dinkelberg, isn't it? Bhop, talk, walk without moving mouse. Stage accelerators are too strong. 13. Bhop arcane. Fall through logs. And then I'm going to open a new issue to track it individually. Fall through logs. Bug 13. We have arcane fall through logs. Create issue. And track this as number 24. So this is an issue that I knew about for years, I guess, but I've just never thought to write it down, which was the point of this entire exercise here, is to write down all the issues so that I can give them a name and start to identify them. And I have just never been able to identify this issue until now. So now, so when the issue occurs, the face crawler always goes through the path, code path. Code path. That's all I know so far. I expect that the face crawler algorithm is straight up wrong in some way which is not easy to proc. Okay. Oof. 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 Didn't mean to do that. This was discovered because the new minimum difference algorithm is much more likely to appears to return correct the correct fev-vert result when the infinity fev algorithm returned an incorrect fev face. Despite the incorrect result, the face crawler correctly finds the collision given the incorrect fev and fails to find the collision when given the correct fev. I have identified a new issue. So the issue occurs when the infinity fev traced path travels through a vertex in the Minkowski sum. Who knew? No, that's not true. The infinity fev traveling through a vertex in the Minkowski sum seems to work fine. It's just when the real crawl after the algorithmic setup travels through a vertex, it appears to be incorrect. So I don't know if it's like edge to vert that's incorrect, vert to edge that's incorrect. I don't know. Hi, it's me. Okay, so upper bound, lower bound, body position, vert. So that looks exactly the same. Times 2 velocity to body acceleration. Haha, what? Is this wrong because it's negative? Edge is directed away from vertex, but you want the dot product to turn out negative. So negative, normal, negative, normal. So what is happening here? If you may recall that I described the space above a face as a Voronoi column of like Voronoi as in like what's the closest point. So this space above the face, the closest point is always on that face. So there's a column of air of space above the face where that is always closest. You could say the same for an edge. The edge could have like a region of space for which the edge is always closest. And so like if you ask what the closest point is anywhere in that space, it's always on the edge. So there's this Voronoi region of space where the edge is the closest. Voronoi is maybe not the best word. Voronoi is kind of closest point. So I guess you could think of the object as like an infinitely dense cloud of points. And then that is Voronoi. So maybe it is applicable. And then it works for an edge, it works for a face. It also works for a vertex. So the vertex has this like corner of space. You can imagine like a sphere cut into three-way. Did I already do that way? 1, 2, 3. And it's cut into eighths and like expanded. And then each of those 8 corners of the center of the sphere contact here, and it goes like out in that direction, out in that direction, out in that direction, out in that direction. So all of the diagonals are closest to the corners, and in some sense, the most amount of volume. It's there's an infinite amount of volume for every single one of them. But I guess if you had a sphere expanding, eventually the corners would take up the most space. What am I talking about? Why was I explaining that? Right. So to actually do this calculation here, I am finding when the closest point, the test point, traveling through space exits this Voronoi area above the vertex, because we're testing a vertex to see if as we move the point, it goes off the vertex and onto an edge. And that happens when the plane at the edge of the edge intersects with the path that the point takes, and it's the first intersection, which is why we're like best transition. So what happened? So we have a vertex. This is the vertex. We have a point that's moving in some direction. And we have the edges along that vertex. So this is an edge, this is an edge, this is an edge. They're always directed away from the edge, from the vertex, rather. So this directed edge normal is a vector that points away from the vertex. It's an edge, it's a normal, it's a vector parallel to the edge that points away from the vertex. And we take the negative of that vector, and I explain here it's directed away, but we want the dot product to turn out negative, this dot product. So when we dot the normal, this normal, with the velocity of the body at the time of it, the calculated time of intersection, we want it to be negative. The face is going this way and the velocity is going that way, so it's going into the face. If it's going out of the face, that means that we're coming from inside the edges Voronoi column, the Voronoi space. But we want to be coming from the vertexes Voronoi space. We want to be going into the edge space. We're transitioning from vert to edge. So that's why this is negative. I think this makes sense. And then what's this? This is solving the time at which the body intersects with the earth, body minus vert. And this is the same equation here as well. Wrap for. Is this bigger? N is 4. Oh, I see. It becomes 5, and I wrap it to 4. Yeah. Okay. It does not look incorrect. I really like how all of these look the same. It's like it's cooked. Dot minus D. Dot minus D. Face ND. Dot minus D. Dot minus D. Good. I wrote down documentation. Ooh, what song is this? It's iconic. Oh, this is someone I know. Okay. Get lost, Discord. I'm conscribulated. I think I need to have time to internalize the implications of this and try to determine a direction to figuring this out. I've written down what the hell going on. Bug 13 proc. New branch. The message prints when you fall through the log. All right. I've created a branch. Bug 13 proc. Which prints a message when you clip through a log. But I don't know the nitty-gritty about what's going on yet. Am I done streaming? I want to like switch up, but like I'm brutalized mentally. Yeah, I think I just go have a snack and sit on this. It's progress. It's progress. Whenever I thought about doing physics this year, it felt like I would never make progress. Like no matter how hard I tried all year, I would never be able to make progress. And every single time I've worked on it, I make progress. So the thoughts were nonsense. It's very slow progress, but I learn new things all the time. I should be able to figure it out eventually. I don't know if I can do it by the end of the year. These bugs are so deep and so fundamental. And mentally draining. And I need to give everything I have to find them. And that's all I have for today. So that's the end of the stream. It's Thursday, right? So no, it's Friday. Yeah. That's all I got. Friday is kind of a hard day. Beaten down all week. Amazing. It's amazing that the new algorithm, I've been debugging the new algorithm all week because I thought it was giving wrong results, but it's been giving correct results that are different than the old algorithm, but the existing code is wrong and doesn't behave correctly when it gets a right answer. It starts breaking when it receives the right answer. It's a lot. All right. Goodbye. I'll see you on Monday. I'll think about this over the weekend or not think about it, but then have new ideas on Monday. That's how it always works. Whether I'm thinking about it or not. Just come back again and again. Goodbye.